Our meetup is where we're posting most of our meetings. And we do have a Slack, and then all of these are going to be recorded and posted on YouTube. And feel free to email any of us directly if you have any questions and don't want to ask it in the Slack channel. Today we're going to do Kubernetes part 2, and then in 2 weeks we'll do Azure app logging. And then November 16th, we're still working out a topic for that. And today's sponsor will be Zerus. With that, I'll kick it off to you, Jeremiah.
All right. Get my screen shared over here. All right, let me know when you can see my screen.
Yep,
can see.
All right, so welcome everyone to today's presentation. This is part 2 on Kubernetes, where we're going to dive into a little bit more of an explicit example of something we can do with our Azure Kubernetes service. So just a handful of slides. We'll keep these brief. Just a quick rundown of our lunch hour today. Tell you a little bit about myself, why I'm giving this presentation. We're going to look over a little bit of terminology and tools, just enough to get us into the space. And then the majority of this lunch hour will be devoted to a demo. So we're going to poke around with a cluster that I have set up with some tools. And we're going to see how that can interact with your existing Azure setup. And then we'll leave some time at the end for any questions. So as far as about me, my name is Jeremiah Evans. I am Director of Research and Technology at Zerus. We are a consulting firm services partner here in West Des Moines. We've been, we've been in business for about 35 years and have clients all over in federal, state government, smaller private organizations, larger organizations. Basically, you name it, we've got somebody in the sector. We do a whole range of consulting services, from integration to data analytics, machine learning, AI, identity management, app development. Again, pretty much we have our toes in a lot of pools. We do a lot of work all over, including in the Azure space. Part of the sponsorship that was mentioned, we are going to be giving away a Amazon gift card for, I think it's $25 at the end of the presentation. So make sure your name is in there for that. As far as a little bit more about myself, like I said, I'm Director of Research and Technology at Zerus, which means that in addition to my normal duties with our clients, I also get to look into kind of the direction that we're going and how we're going to keep our clients relevant in the changing landscape. And with that focus, in particular in the Midwest, obviously we technologically tend to lag a bit behind the coasts, even as advanced as our local firms are. So kind of knowing when the right time to bring in this new technology is a big part of what we try and do. On the particular topic today of Kubernetes, I have spoken about Kubernetes at a couple different events, the DevOps Online Summit, AIM Infotech, and the ITA Tech Summit, to name a few, talking about, in general, Kubernetes, DevOps, how that interacts with other systems, and just the culture of DevOps that it is important to have in your organization. Probably the biggest reason why I'm giving this presentation is I remember Kubernetes 1.3. Right now we're on 1.21. My first exposure to the product was fairly early on in its development. And so I've been able to watch some of those changes and see its evolution from something that, yeah, you could roll it yourself in all these different cloud platforms, to something that's actually become a part of not just Google's ecosystem where it spawned off of, but something that you can actually get a managed service in your various cloud environments, in particular today in Azure with AKS. So brief overview of terminology and tools that will be important for today. First one is, this is part 2. So if some of the concepts or anything kind of is not quite clicking, not quite landing, it might be because we covered it in our last presentation, my last presentation, Kubernetes Basics. You can find it here on the IO Microsoft Azure user group channel. And it's the Kubernetes Basics from, that was, I can't read dates, back in August 10th. So again, if you're looking for more of a basics introduction to what is Kubernetes, what is the Azure Kubernetes service, how to work with it, this is what you're looking for. But we're still going to keep things fairly high level and more just of a demonstration of the things that it can do. So this is good information, but shouldn't be necessary to comprehending today's presentation. And now it's going to try and play that, which is not what we want to do. There we go. The tools in particular we're going to be looking at today are Kubernetes, specifically AKS, JupyterHub, which we'll talk about in a little bit, and then the Azure products Cosmos DB and SQL Server. Those will be our data sources for our demo today. So JupyterHub, if you're familiar with data science notebooking tools, JupyterHub is a evolution of the Jupyter notebooking tool. Notebooking tools are just a way for data scientists to have an interactive environment that allows for importing and exporting of data, management of libraries, interaction with graphical and sometimes even interactive results. And that is just a space that has exploded in the last probably 5-10 years. So where Jupyter Notebooks was more of a less a less flexible solution when it first started, what they've been able to do is bring it into this JupyterHub, where instead of just individual notebooks or an individual notebook server, we're actually able to provision individual servers for users and go through this hub and spoke model where you have an HTTP proxy sitting up front that's going to forward all of our traffic, forward all our requests. Everything's going to go through the hub, which is going to allow for your centralized authentication, management of sessions, things like that. Have your various configurations for your environment, what tools are available, what your user groups are going to look like, things like that. Have some administrative tools in there. Have this plugged into whatever your preferred authenticator is. And then these spawners. So the way that JupyterHub is designed is to be a flexible and self-service data science environment. The idea is that as a infrastructure manager, as a systems operator, as a DevOps technician, you don't want to be handling the request to spin up and spin down services. You don't want to be handling the request to spin up and spin down servers. The point of containerization, the point of DevOps pipelines is really to automate as much of that as possible. And that's not just in terms of infrastructure as code and scripting that out, but it's also in giving the users the privileges and the tools that they need to safely manage their own resources within whatever greater boundaries you specify. So the way that looks is our JupyterHub is going to spawn a notebook server instance for every individual user. These are going to be isolated Kubernetes pods. In this case, it has a couple of different plugins. The version we're looking at today is the Zero to JupyterHub Kubernetes project, which is going to use the underlying Kubernetes cluster to support this mechanism. So when a user signs on and needs resources, it is going to give them an individual server that is going to have particular persistent data associated just to that user. So you're able to have a separation of the data of every individual user to make sure that your privacy boundaries are set up correctly. As we mentioned with Kubernetes before, you can also mount shared directories in here too. So if you have, for example, an NFS store where you're dumping files, or a GPFS cluster, or some other place where you want to land data and make it available to all users, you can mount that as well so that users are able to access their shared data in addition to the persistent, unique areas that they have to work with as well. And again, this is all browser-based and is basically a data science IDE in your browser that is automatically provisioning and deprovisioning these resources, which in that cloud world is incredibly important. We want to make sure that we are able to give users the flexibility and the speed that they need to access their data and access their tools. But we also want to be able to do things like call an idle server and say, if this server hasn't been active for an hour, we're going to spin it down. Or say, this is the maximum amount of capacity that you're allowed to access, things like that. So we're able to set our limits and understand what the cost of this is also going to be in a cloud environment. As far as the data side, we're going to take a look at Azure SQL and Cosmos DB, more just for this is where we're storing data. I just wanted to show that we can interact with all of those components from our Jupyter notebooks. But also we're going to look at a feature, especially of Cosmos DB and then the Azure Data Explorer, that kind of point to why Jupyter Notebooks and notebooking is such a powerful tool and something that you're going to want to be familiar with going forward. With that, I'll open it quick if there's any questions off the bat right here. Otherwise, we are ready to go into our demo. All right, I'm not seeing any questions. And of course, at any point, if you want to throw a question in the chat, I think we've got some people watching the chat who can answer those or bring those up to me as well. With a smaller group here, this can be fairly interactive. Okay, so the first thing we're going to take a look at is just our Azure Portal, looking at the components we have in here. The things that we're looking at today are our ZDev Kubernetes cluster, our Cosmos Kubernetes, Cosmos database, our SQL DB, and a container registry. These are the specific components that are going to go into our solution. So we've looked a little bit at the ZDev Kubernetes last time, but I want to dive in here for those of you who weren't able to make it to the initial presentation, or even just as a refresher for those who were. So one of the benefits, the chief benefits of Azure Kubernetes Service is the monitoring and the integration with your portal. There are other tools. There's an open source Kubernetes dashboard that's available if you are just managing your own. Obviously, Google has their own management system for the Google Cloud Engine, which is what Kubernetes spawned off of and effectively is. Amazon has their own version, which also has monitoring and integration with CloudWatch and things like that. Of the three, and I've worked with both a homegrown cluster that was just on EC2 resources in AWS. I've worked with an AWS EKS cluster, and I've worked with this AKS cluster as well. Of the three, the AKS dashboard is the most robust that I have seen. It is definitely better in terms of performance and security than the open source version, the free version. There's a lot of users who just go to the shell or the command line right away. And so not as much attention is paid to integration with a particular logging framework because, of course, a roll your own solution needs to be pretty flexible. But that benefit is here where you have access to your activity log, all of your IAM components, tagging, security, et cetera. You have access to your namespaces. Remember, namespaces are just a way for us to separate resources. So we're going to have these cube-specific namespaces that hold specific components. For example, for our cube system, which is going to hold, see what all we have in here. That's just the namespace. I need to go to workflows to see that. There we go. So if we look at some of the pods that are in Kube system, we see like our core DNS, our metric server, Kube proxy, things like that are going to exist in the Kube system. Those are things that are managed by AKS. This is the control plane component that we talked about last time. Those are the things that we don't have to worry about. The only things we're actually concerned about today are in this JHub namespace. And so let's go ahead and filter by JHub. These are the things that we have we've created a JHub namespace, we have deployed the JupyterHub tool, and these are the components that actually live in there. And again, just as a refresher, so in this case, most of these components are deployments. Deployments are just a way of managing the template of a given pod. A pod is a collection of one or more containers that are running the actual meat and potatoes of the system. So in this case, if we, again, filter by JHub and look at our deployments, we have a hub, we have a proxy, we have a user scheduler. If we're looking just at the pods, we're going to see those actual components, including a Jupyter Jevons, which is my actual server that it spun up for me. And again, you have access to all of your insights. You have access to configuring your node pool, so you can define the type of resources that are going to be associated with your Kubernetes cluster, things like that. So I want to go back up a level, and we're just going to take a look quick at our container registry. Of course, you can use an external one such as Docker Hub. In this case, we are, there we go. So we are using baked in Azure repository. There's just a simple command that will authenticate between your ACR and AKS, basically just opening up a firewall there and say, hey, it is okay for AKS to go ahead and hit this repository. In this repository, I have, in this case, just my JupyterHub single user. I have a couple of versions in there, but these are just Docker images that are going to be used for my JupyterHub experience. And then let's take a quick look at the other two components here are just some data that we have, just some sample data in here. We just have a SQL database and then a Cosmo database as well. And this, of course, just has the interface you'd expect here. And we can take a look at Data Explorer. We have some sample data in here that we can review. So you see we already have some data loaded in there just so we can show how we would access this through our Jupyter component. All right, so let's dive into Jupyter. So the first thing you're going to see is the launcher. And this is really what I said. It is a browser-based IDE. This version of it is configured with a Python 3 kernel. Kernels are just the execution engines that run on this. There are a wide variety for Python, R, C#, Java, F#. Just in interest of time in preparing this, I stuck with Python libraries. Python is one of the bigger languages in data science, but you can get very granular with this. And we'll see some examples of that when we look at the notebook components that Microsoft has associated with some of their Azure components. So within here, we have a file browser over here. In this case, we have a couple of directories here. We'll take a look through, have some examples in them. We have just some management tools to see running components, table of contents if we have that. We have some extensions here. JupyterHub is incredibly customizable in all the ways that you would want an IDE, even down to, right, I can just change my theme around. So, whatever your preferred theme is, things like that, just to make you as comfortable as possible within the environment. And as far as the security component as well, since these are based off of Docker images that you control, you specify what's going to be used, you can lock those down as securely as you want. And you can lock this environment down as much as you want. So for example, I have one client where there is absolutely no access to the internet because of the sensitive nature of the data that they're working with. So everything has to go through the build pipeline. Everything has to be in place by the time we build. There might be a more open source or more kind of open door policy for data that's not as sensitive that would allow users to directly interface with the internet and have a little bit more of a customizable environment. And JupyterHub is going to support all of that. So let's just dive in and take a look at some of the things that we can do with JupyterHub. So first thing we're going to take a look at is a weather example. And we're going to open up two versions of this. So we have these IPyNYB, IPython notebook is the extension. And you can see I can drag and drop these windows around. And I have two examples of this so we can take a look at how Python is going to do this, how Jupyter is going to present it, and then integrating with an actual database. So in this case, I'm reading from a CSV file. I just pulled this from 538. They have tons of sample data sets. So this here is the US weather, and we have a handful of, right, we can pull up different CSVs. You can see JupyterHub is able to recognize that it's a CSV file and show us in a tabular format. So we can edit it right in there, or we could also go ahead and edit it with just an editor to see the raw CSV file. You'll also notice we've got our syntax highlighting for Python. So we're going to do this one first. Go back to Python, weather. All right, so within our config directory, we have a couple of components in here just so we're not staring at a bunch of code. We've got the example weather.py that's actually doing the work of generating our various plots and printing those out. We have a style guide that's going to be used by this. And then we have just a config.py that's going to have our details for our connection string, so we can keep that out of the main notebook. So we're going to go ahead and run this. By running it, I can click the run button up here, or there's a couple of keyboard commands I can use as well. You'll see that star indicates we're running a particular cell. And you can see here that this is listed as busy. We're going to see some outputs as it works. So it's loaded in that CSV file as a pandas data frame, and then is going to print out a variety. Move that up and out of the way so we can see the whole. So it's going to print out this whole series of graphs and charts. And then I can save this and I can export this to whatever format I would want. So for example, we can export it as HTML page using LaTeX, as Markdown, PDF, Reveal.js slides if you're familiar with that. So we have a lot of ways to pull the data out of here. And back here, so we see it generated these images and then inserted them into the notebook. So we can view them here. I'm going to go ahead and delete these. And we're going to take a look at that same example, but this time we're going to be using our SQL database. So we're going to run this first one just to do some setup work. So our imports, pulling out our values, getting our connection string set up, for example, and see that we can just go ahead and run that. We just did a fetch 10. Obviously, this is going to be good for debugging, but doesn't tell us a whole lot. We can see it read in as a pandas data frame. We can just read SQL query from that connection. So we can take a look at it from the data frame perspective, and then we can pass that in to the same Python and see we get the same result. See, it creates all those images, and we can go ahead and open those. It'll show. And there we have those results. The nice thing here too is it's going to autosave. If we go in, we see autosave documents is already checked. If I go into the advanced settings editor, and actually go into the document manager, and I can change that default interval of 2 minutes. So I can change this as I need. Like I said, there's a lot of customization. We're not going into this today, but highly customizable for your particular needs. The other nice thing is I can save this, and then when I close it and reopen it, you can see it's actually going to have the output. The output is saved as whatever the output status is. That's saved as part of the notebook. So you don't necessarily have to rerun this every time you open it. You can save the output, leave, and even if the whole server goes away. So for example, if I go to the Hub control panel and I stop my server and I wait a second, and we're going to go back over to the Kubernetes, and we're going to validate that it is in fact gone. Loads, pods, JHub. We see that JupyterHub is no longer there. I'm going to start my server. Depending on how many components you have, this usually takes less than 30 seconds. That configuration is configurable. That timeout is configurable. And you can see we've got it coming up. I can inspect this, check out the containers, the volumes, the conditions, and get like live logs on this. See, it hasn't admitted anything yet. And then when that's done, it's going to pull it back up. In an experimental zone. And we go back to Python, weather, and we see all of those are still here. And if I look at, see that all of my stuff is saved just like it was. The other nice thing with a notebooking tool is that one of the things we can do is we can make changes and rerun things. So for example, let me take these out. And we're just going to add a new cell. And we're going to say we actually only want 5 records for our partial. And we can see that's run. We need to run that again, make sure we have our imports. Okay. Go. And then, again, this example of where if we are a little bit more permissive, we can actually let users get the libraries that they need. But you can see that it goes in, you can also see that there we go. And so these are components, again, you can either have these in a shared location that users can use. If it's a more open environment, you can let users install these as necessary, or you can make them as part of the total install. So if we go here and we see our query is down to 5, we can bump that back up to 10. See, this has gone to 6, and this has gone to 7. So you can see that execution order. We can also do a number of things through our right-click menu, including clearing outputs, creating a new view for the output, which is just to see, let's see, which one was that connected to? Let's make sure that's connected to the right one. There we go. So you can highlight just a specific cell, get that output in a separate window. And you can create a new console for Notebook. So console is just your Python idle engine. So if I go in here and I take a look, and I'm going to see my state from here is replicated in here. So if I want to do something more of a command line interface, I can do my individual tweaks here, and those are just going to be in the same execution order. So if I wanted to take a look at, say, the weather data, say it's not defined because I haven't run that cell yet in this instance. So we run the weather data, and we run the weather data, and there it is. Other things we might want to do with our environment is we can go to our view here. We can collapse outputs, collapse and expand outputs and code. We can do that through here as well. So if we just want outputs, we can insert markdown or raw text in our notebooks. Because again, the notebook is not just about the code and the analytics, but it's also about the data story. It's about giving context. And so we can do that with markdown, raw text, etc. I can also, if I'm having issues with my particular kernel, I can interrupt it. I can restart it. For example, I can restart the kernel, clear all the outputs. So that resets my state all the way to 0. Go up here, and we're just going to run all cells. You can see it's going to go through. And execute those all again. And then it'll update those as well, overwriting those old files. Close those, go and save that before closing. And we're going to go over to Cosmos. Just want to show you an example there as well. There we go. So in this case, let's go ahead and clear all, restart kernel and clear all outputs. So in this case, we're using the Azure Cosmos client library, which is a Panda, or it's going to be a Python library. So we're going to run that. Again, we could separate this into as many cells as we wanted to, but we're going to get our config. Config is just going to hold the information we need to hit that specific Cosmos database. Pull that out into some variables, set our container link, feed options, a basic query, create the client, run that just like you would expect from any sort of Python programmatic access. Now in this case, we just dumped all of the data out there, but we're going to go ahead and clear our outputs and run this here to see that we can take that output JSON from whatever our query was from the Cosmos documents and also import that into a Pandas data frame. So whatever subsection, cross-section we need to do of the data that's in that table, we can pick our specific documents and then we can transfer those over to a pandas data frame to do our analytics on, whatever that might be. And of course, again, these examples aren't all in Python, but we could be doing this in C# and F# and Julia in R, or any of the other, excuse me, any of the other supported languages for JupyterHub, which is really just kind of the sky's the limit. So if we take a look at some of the components that are in the extensions library, there's a fair amount with LaTeX and being able to pull down Git repos, etc. So there's a lot of options here, as well as just adding new kernels. So for example, with a current client we are doing integration of Python, Stata, and R, and being able to move back and forth between those three in a single environment through a single IDE. And in this case, they had a requirement where the Stata IDE provides some tools that the command line component of it didn't in terms of crafting some of the queries. And so we were able to use a Jupyter plugin that actually spawns up a nested server of just that IDE. And so we're able to host it from the user's single user server. So it's accessing everything that the Jupyter IDE is accessing. It's all part of that same container. It's all isolated from other user processes, both in terms of security, but also in terms of the resources being used. So again, there's a lot of flexibility to whatever the specific needs of your users are. So that's, again, just a pretty brief overview of some of the things you can do with Python. I want to take a look just a bit at the behind the scenes. So the components that let this happen today are the 0 to JupyterHub K8s project, K8s Kubernetes. In particular, we have this image, excuse me. So the majority of the work here has been in customizing the Docker file, just adding the particular components we want to make sure that the right libraries are present and the right tools are available. So this Docker file gets built into an image, and then that image is what is actually created into a container when a user spins up their machine. And you can customize both the single user server as well as the hub. So for example, here's the Docker file for the hub and the components that are going to be on there. So any sort of configuration you need, any kind of defaults you need are going to be present there. Then to do this, so that's, we create that create that Docker file, we push that container to our Azure container repository, and then we need our config. This config.yaml is for Helm charts. Helm is a deployment tool for Kubernetes. Helm version 3 is a vast step forward from previous versions because it no longer requires any installed component. So if you're looking into Helm and you're saying, why do I need to install Tiller? You're on too old of a version of Helm. So upgrade to Helm 3. Helm 3 is a client that's able to connect to your Kubernetes cluster using your Kubernetes credentials and manage releases of your components. When I say release, the configuration files are going to be several. When you're looking at deploying something to Kubernetes, again, this is something that we looked at in our Kubernetes Basics session. But for example, you're at a minimum going to have probably a deployment, a service, possibly some config maps or secrets. And then these are going to need to be parameterizable, so you can specify the environment that they're going into, or as you tweak things like what the secret it should pull in for the password, what the password repository should be connecting to, things like that. You're going to want to have those as something you can parameterize. And so what Helm does is it gives you a chart which has all of these base components as templates that can be parameterized and generated into the actual deployment resources. And then it tags them and it manages them so you can update and roll back and delete as a whole block. So you're not worried that you're missing anything. And it's able to know what components can be just updated, what components need to be deleted and replaced, things like that. In this case, the reason we only have one file is because the default values for this deployment are already baked in. In fact, you need this config.yaml file, but all you need is the file. It doesn't have to have anything in it. However, we are going to do some customization. So for our hub, we've specified we're going to use a dummy authenticator, which just uses a super basic password and has an admin user and a couple of allowed users. Then for the single user server, we're specifying we're going to use this zdevk8s repository that we looked at earlier, tagging it with image number 2, default URL to the lab, that's just the interface that we were looking at, and giving a couple of other basics around the extra environment, as well as our memory and CPU limits and guarantees. So we're saying this is going to get 1 gig of RAM and it's going to get a half of a CPU core when it's executing. Again, these are all customizable to your specific needs, but for demo purposes and for investigation purposes, this does just nicely. So the actual deployment process is pretty straightforward. All that you're going to end up doing here, I'm going to copy this into a new notebook so you can see a little bit easier. Possibly. There we go. So we're just going to run this Helm upgrade command, telling it to install the JupyterHub release using this chart into this namespace, the version of the chart, and specifying for values our config.yaml. There's also the ability to override individual commands at this point. So again, highly parameterizable and lets us use templates that have as minimal actual file changes and as much as possible passed in through either a configuration file, which could be environmentally based. So this could be dev config.yaml, test config.yaml, et cetera, or through overrides where you set a particular parameter. And so that Helm upgrade will install, and we actually have the Kubernetes here. You can see I'm in Visual Studio Code. Has a number of extensions that make our lives incredibly easy when we are working with Azure anything, but in this case specifically Azure Kubernetes. So for example, we have the Kubernetes plugin, which I was able to just authenticate with my Azure credentials, and it pulls up ZDev Kubernetes. I can see all that information in terms of my namespaces, in this case making sure I'm on the JHub namespace as my specific default. There we go. So here I could say use this namespace, and then I would be seeing things in particular to kube node release when I really just want JHub. I can see the nodes that have been built. I can see what components are on those nodes. In this case, looking at the Helm releases, I can see I've got JupyterHub, and my version 6 was deployed 3 hours ago. To give you an idea of how quick this can be, I'm going to go ahead and we're going to call this JupyterHub 2. You can see release JupyterHub 2 does not exist. Well, let's just do the upgrade then. And as quickly as that, it has processed a new release. I could also roll it back either from here or by going in and selecting a previous deployment and rolling it back. All right, and then the last piece I wanted to show you quickly was in here. Let's see which tab was it? There we go. So you'll notice that this is actually an IPYNB. It should be familiar. So this is the Azure Data Studio, and this actually lets you use notebooks for, in this case, your SQL Server, and you can also enable notebooks for your Cosmo DB. So if you have a smaller need that is just looking at a particular database, then it has a built-in Jupyter notebooking system, so you can specify the kernel, this case SQL, PySpark, Python 3, PowerShell, etc. Select which connection you're attaching it to, and get your output that you can interact with. So again, this is not going to be as flexible as the JupyterHub solution. This is going to be tied more directly to a specific instance. So if you're trying to bring in data from multiple sources, this is not going to do as much for you and does not give you the same level of control to make sure that users can spin up their own resources and have their own persistent states, et cetera. But it very clearly shows that the Jupyter notebooking interface and connectivity is something that is recognized. And so that familiarity is going to serve you in different applications. And you're going to find some of these notebook examples that are maybe built for this that you can just import into your Jupyter Notebook solution and give you the same level of insights and give you that same access into your data, but again, from that more multifaceted platform that we have. So with that, I'll go ahead and open the floor to any questions or further discussion. As we get into that, again, my name is Jeremiah Evans. There's my email, jeremiah.evans@zerus.com. So my focus is more in, as I said, the Director of Research and Technology, but also in data integration and infrastructure as code. We also have Madison Lang, who has presented to this group before, who's the Director of Machine Learning and AI Services. And so if you're looking for more information on the actual data science components, so putting this to use, right? I deal more with the how to set it up and manage it from the infrastructure and data flow components, but then actually putting it to use and making sure you have the right libraries and getting your algorithms into this and getting your data scientists, letting them loose on this. That's going to be more of Madison's department if you have any further questions along that line.
Any questions for Jeremiah? If I like, I can stop the recording and you can ask off recording. So I'll go and stop recording.